Chapter 13, Fluids. This lecture will help you understand Bernoulli's principle. Fluid flow is the motion of a fluid subjected to unbalanced forces or stresses. The motion continues as long as unbalanced forces are applied. The river flows because the unbalanced force is gravity. Laminar flow, also called streamline flow, is a smooth, steady flow of constant density fluid. Turbulent flow, also called non-laminar flow, is flow speed above a critical speed and becomes chaotic. A car spoiler breaks up laminar flow, releases the suction, and decreases the drag or frictional force on a car. The volume of fluid that flows past any cross-section of a pipe in a given time is the same as that flowing past any other section of the pipe, even if the pipe widens or narrows. Fluid speeds up when it flows from a wide to narrow pipe. Motion of fluid follows imaginary streamlines, which are drawn on the figure. The flow rate of a fluid is defined as the volume of fluid flowing past a given point in a pipe per unit time. Assume that we have a streamline flow through a straight section of pipe at steady speed v. During a time interval of delta t, each particle of the fluid travels a distance v times delta t. If A is the cross-sectional area of the pipe, the volume of fluid passing a given point during that time interval delta t is the volume of the cylinder formed by V delta T times A. Thus the flow rate Q is the volume passing the point divided by the time interval and is the velocity of the fluid times the cross-sectional area. For an incompressible fluid, the flow rate is constant throughout the pipe. The overall volume rate of flow of water in a stream or creek is relatively constant. That is, the volume of water passing through the various sections is constant. Thus, the speed of the water increases within sections where the stream is narrow and decreases within sections where the stream is broad. If the cross-sectional area of the pipe changes and streamline flow is maintained, the flow rate is the same all along the pipe. That is, as the cross-sectional area increases, the velocity decreases. If the cross-sectional area decreases, the velocity increases. Water flows from a pipe at 650 liters per minute. What is the diameter in centimeters of the pipe if the velocity of the water is 1.5 meters per second? Find the velocity in meters per second of water if the diameter of the pipe is 20 centimeters. The cross-sectional area is that of a circle. With diameter d, the area is pi times d squared divided by 4. With a given value of q and knowing that 1,000 liters is equivalent to 1 cubic meter, the diameter of the pipe must be 9.6 centimeters. Using the flow rate equation again, the pipe has a cross-section of a circle of area pi r squared. With a diameter of 20 centimeters, the radius is 0.1 meters. This means the velocity is 0.34 meters per second. A garden hose is used to fill a bucket in 30 seconds. If you cover part of the hose nozzle so its speed of the water leaving the hose doubles, how long does it take to fill the bucket? Answer is 30 seconds. The volume flow rate is constant. Bernoulli's principle was discovered by Daniel Bernoulli, a 15th century Swiss scientist. It states that where the speed of fluid increases, internal pressure in the fluid decreases. This applies to a smooth, steady flow. Streamlines are thin lines representing fluid motion. Closer together, flow speed is greater and pressure within the fluid is less. Note the larger bubbles. Wider flow speed is less and pressure within the fluid is greater. Greater pressure squeezes bubbles smaller. The Venturi effect is the reduction in fluid pressure that results when a fluid flows through a constricted section of pipe. Atomizers or spray paint, some vacuum cleaners, recoilless riflers, scuba diving regulators all utilize the Venturi effect. The Venturi meter shows that the higher the speed of a fluid through a tube, the lower the pressure. The lower the speed of a fluid, the higher the pressure. What happens to the internal water pressure in a narrowing pipe of moving water? A. Pressure is higher. B. Pressure remains unchanged. C. Pressure is less. D. None of these. C. Pressure is less. This reduction in pressure would be apparent if air bubbles were in the flowing water. Note their size increases in the narrow part due to reduced pressure there. Moving air gains speed over the roof of a house. This change in air velocity means reduced pressure on the roof. Therefore, air pressure inside the house is greater, which can raise the roof. The pressure in a stream of water is reduced as the stream speeds up. How then can a stream of water from a fire hose actually knock a person off his or her feet? A. It can't, as Bernoulli's principle illustrates. B. The pressure due to water's change in momentum can be much greater than the water's internal pressure. C. Bernoulli's principle works only for laminar flow, which the stream is not. D. None of the above. Answer is B. The pressure due to water's change in momentum can be much greater than the water's internal pressure. There's a basic distinction between the pressure within flowing water and the pressure it can exert when its momentum is changed. The pressure that knocks one off his or her feet is due to the change in the water's momentum, not the pressure within the water. Another application of Bernoulli's principle involves airplane travel. Following the flow of air rushing past the wing of an airplane, the velocity of the air above the wing is greater than the velocity of the air below because it has farther to travel in a given time. Thus, the pressure below the wing is greater than above the wing, which causes lift on the wing. The vertical vector represents the net upward force lift that results from more air pressure below the wing than above the wing. The horizontal vector represents the air drag force. Air speeds up and is blown across the top of the vertical tube. How does this affect the air pressure in the vertical tube and what then occurs? A. The air jet pulls liquid up the tube. B. Liquid mysteriously rises in the tube. C. Reduced air pressure in the tube due to Bernoulli lets atmospheric pressure on the liquid surface push liquid up into the tube where it joins the jet of air in the mist. D. Liquid in the vessel somehow turns to mist. Answer is C. Reduced air pressure in the tube due to Bernoulli lets atmospheric pressure on the liquid surface push liquid up into the tube where it joins the jet of air in a mist. When the speed of water increases between boats, Bernoulli must be compensated for, or else the boats collide. Bernoulli's principle explains why a baseball curves. As the spinning ball moves through the air, it creates a pressure difference between its two sides according to the Bernoulli effect. The interaction between the air layers on the side of the ball that rotates in the opposite direction of the ball's movement and the surrounding air creates a low pressure system. This will suck the ball and curve its trajectory. And this is known as the Magnus force. The following are a set of problems for you to work on. Pause the video to give yourself time to work on the problems. Question 1. Which is more likely to hurt, being stepped on by a 200-pound man wearing loafers or being stepped on by a 100-pound woman wearing high heels? A. Pressure would be appreciably greater by the woman, which would hurt you more. B. Pressure would be appreciably greater by the man, which would hurt you more. Pause the video to work on the problem. Answer is A. Pressure would be appreciably greater by the woman, which would hurt you more. In a hydraulic arrangement shown, the larger piston has an area that is 50 times that of the smaller piston. The strongman hopes to exert enough force on the large piston to raise the 10 kilograms that rest on the small piston. Do you think he will be successful? Pause the video to work on the problem. The strongman will be unsuccessful. He will have to push 50 times the weight of the 10 kilograms. That is 5,000 newtons, 1,124 pounds, more than his weight. The hydraulic arrangement is arranged to his disadvantage. Ordinarily, the input force is applied to the smaller piston and the output force to the larger piston. This arrangement is just the opposite. The weight of the atmosphere above 1 square meter of Earth surface is around 100,000 newtons. Density, of course, becomes less with altitude, and the top of the atmosphere is around 50 kilometers. But suppose the density of air were a constant 1.2 kilograms per cubic meter. Calculate where the top of the atmosphere would be. Pause the video to work on the problem. Using our pressure equation, the top of the atmosphere would be 8.5 kilometers. Find the water pressure at the bottom of a 51-meter high water tower in the figure. Pause the video to work on the problem. The pressure at the bottom of the tower is around 500 kilopascals. A 1.4 meter tall barrel is filled with water with a weight density of 9,800 newtons per cubic meter. Find the water pressure on the bottom of the barrel. Mercury is 13.6 times denser than water. If another barrel twice as wide and half as tall were filled with mercury, what would the water pressure be at the bottom of the barrel? Pause the video to work on the problem. The pressure due to water is 13,700 pascals. The pressure due to mercury is 93,100 pascals. Your assignments are to read Chapter 13 in the textbook and watch the online videos. Your homework assignments are due April 20th.